Hello, what's up? It's Papa Bale, and welcome to the channel. Okay, so I've heard a lot of stuff about counter-rotating fields and their possibilities. So I just thought of an easy way to make two simple counter-rotating fields that are virtually in the same field. Now, I mean, it is in question because what I'm doing here is I got all north out facing on the bottom one. And then I got a toroid that's south facing down. So all that area in the middle that's south. Oh, where's my thing? I'll be right back. I got a magnet tester. I gotta find it. Alright, I got it. Okay, so they're all facing north out. They're being held in place by the toroid on the bottom of this one. Both of them are. So there's pressure being applied to the ones on the bottom, and then there's the north is sucking the south end of these ones into the toroid. So it's very secure. The only problem we have is when the top one gets going, the shaft starts to shake a little bit. All right, so let's spin it real quick. So you get that, and then as you move in all the way to the shaft, all the way through to the other side, it's all south. So we got the north facing up on the bottom, holding everything in place. So this thing could go really, really fast if I wanted it to, and it would be all right. Now I've centered the toroid as close to perfect as I can get it. All right. And I think it's a little off because this thing shakes a little bit when it gets going, like I said. So I'm going to start this up. I'm going to spin. So 5.5. We'll go through the circuit. Got a SSG for the bottom and a 1, 2, 3 for the top. Okay, so now you saw that I spun the bottom one clockwise and the top one counterclockwise. And we can switch that up if we find it necessary. Alright, so let's look at our little meter here. Wow. And this is all south. And then in between these is all south because it's repelling south. And then the north is on the outside. Let's see how far out north reaches. Right to about there. Let's move away from the coil. So right about there. Oh, you see it starting to shake though. I'll turn it down. Three and a half. You're really not drawing any amps when you're down below 3. So we'll go straight to 3.05. There, that's stable. So I'm just worried. I'm like thinking about ways to get these two closer. So that north is going out to about right there, and the south doesn't reach to about right there. That's cool. So really close you get a south. And in between you get a south as well. Like in between, that's probably what's going on. And you get close enough and then that south gets pushed out. South is being pushed out. All the way out here, man. South is being pushed out. And it's being pulsed. So that's pretty neat. The south is being pulsed and pushed out about this far. So the interacting fields are, even though it's all south, it's being pushed out like really far. And then I think the north is actually reaching out a little bit farther than the south. That's awesome. Wow. If you can imagine that, just imagine that. Because it's being pulsed, you see? Because it's 4 magnets, so it's being pulsed. So cool. So what would that look like? I mean, if you could see the magnetic field, just what we're measuring right here. If you could see that, like in color or like another way. Right now we're kind of looking at it in color. And I right now I think we're going really slow. We're at like 3 volts in, man. We're going slow right now. And we're still getting some pretty phenomenal readings. So it's slowing down. Still slowing down, I should say. From it going so fast earlier. There we go. Now we're, oh, yeah, something. So about 2,700, 28. Eight times 4. Yeah, okay. So that would be about 700? Right around 700 RPMs. So I don't think anything mythical is going to happen like this, but it's pretty awesome to see the magnetic field like can be measured way out here. That's sweet. And I'm not saying this is like specific to what I'm doing. I mean, I think other people have made experiments like this to measure how far. They used different methods, though. So yeah, I think it's awesome whatever way you do it, and I think I might. I don't know if I can make a pickup coil that'll like be tall, like this. And it'll hit both of them, or it'll be a stand that'll hold 2 pickup coils. You know that it's built for this specifically. And then we've got another rotor for this too. It's a off-size one, but it's 4 magnets. It's a big one. It's got powerful magnets in it. But the same toroid setup. Virtually rests on the one on the bottom, and they can spin in different directions. So I think it's cool that, you know, it's a pretty controlled environment, and you can run any kind of like test you want to on this, and it's cool. It's not like any of the other counter rotators that I've built, because there's 2 motors to it. All the other ones, the coils are moving. This is 2 rotors. So it's not really like a counter rotator where the stator's moving. It's just 2 counter rotating rotors, and I've tried very hard to describe it in a way as such so people get it. This is not like a counter rotating motor that I built before. This is just 2 counter rotating rotors on the shaft, with 2 motors, 2 power inputs. You know, this is just to experiment with the field. It's not to make anything, you know, too tremendously exotic. I think it's great. Thank you very much. Peace out. Have a wonderful night. Bye now.